Hello everyone. Today we are going to solve a problem which is gate problem of 2017 on pile formation. So we have a H pile which is driven into the ground. So let us take a pile which is driven into the ground, and the average surface area of the pile is given to you as 3 meters square per meter length, and the soil at the site is sandy soil having an effective friction angle of 32 degrees. The groundwater table is at a depth of 2 meters below the ground surface. So groundwater table. So 2 meter is 0 meter. So from the ground level at a 2 meter. And the unit weights are given to you above and below the groundwater. So above the groundwater it is gamma equal to 16 kilonewton per cubic meter, and here gamma saturated is given to you as 19 kilonewton per cubic meter. Assume the earth pressure coefficient K equal to 1, delta equal to 23 degree, and you will have to find out the total axial frictional resistance. So mobilized on the pile that we need to calculate. So above the water table up to 2 meter depth, and this is 7 meter. So up to 2 meter depth we should calculate the unit skin friction Fs1. So you know that the unit skin friction up to Z equal to 2 meter just above the groundwater table. So Fs1 will be given by K times gamma into Z into tan delta. So this will be K equal to 1. Gamma is already given to us as 60 up to 2 meter multiplied by delta and 23 degree. So if you multiply it, you can get the value. So 16 to the 32. Let us calculate 32 multiplied by tan 23. The 13.583 kilopascal. The unit skin friction Fs1. So at Z equal to 0, the value will be 0, and it becomes here at Z equal to 2 meter, it becomes 13.583. Right? Now go below the groundwater table. So if you go below the groundwater table from here, let us go from for Z equal to 2 meter to 7 meter. That is, under the water table we should calculate Fs2, the skin friction here. So skin friction here will be here again at this Z is going to be 0, so it will be 0 here, and then K equal to 1. Gamma is going to be now somewhat unit weight, so 19 minus gamma W, so gamma saturated minus 9.81, so 19 minus 9.81, that is the value of gamma prime into Z is going to be from 2 meter to 7 meter, that is difference is going to be 5 meter. So Z equal to 5 and into tan 23. So this, if I calculate, let us calculate this. 9.19 multiplied by 5 into tan 23. So 19.504 kilopascal. So here, from here, this one is 19.504 kilopascal, right? From this expression you can find it. So this is how the unit skin friction variation of unit skin friction Fs can be like this, and this is going to be 13.583 and this is going to be 9.50. Now, to find out the total load transfer through skin friction, we will have to find out the load transferred through skin friction in zone 1, that is up to 2 meter. So it will be FS1. FS1 is 13 point, now it is here 0. So you can say 0 plus, here it is 13.583 divided by 2 multiplied by AS1, the shaft area. Now what is the shaft area? This will be 0.5 multiplied by 13.583, and shaft area, here it is already given to you, 3 meter square per meter length. So for 2 meter, it is 3 meter square per meter length. So total length is 2 meter. For first 2 meter we are calculating QS1, so into 6. So if I calculate it, so QS1 will be, let us calculate 0.5 multiplied by 13.583 multiplied by 6. So it is 40.749. So it is approximately 40.75 kilometer. Now go below the groundwater table and find out QS2. So if I go below the groundwater table, I can calculate it. So let us calculate QS2 now. QS1 is known. Now very easily we can calculate QS2. So QS2, load transfer through skin friction from 2 meter to 7 meter. So in this zone, what is the variation of Fs? It is 13.58, okay, rectangular, multiplied by shaft area. So shaft area is going to be 5 meter multiplied by 3 meter square per meter. So into this plus, due to this triangular variation, it is 0 plus 19.504 divided by 2, right? For this, half into base, this into height. So height is going to be 5 and the area will be into 3. So QS2 also we have been able to calculate. So this is going to be 13.583 and this is 5. So you will have to surface area, you will have to multiply it with the surface area this Fs value with surface area. So this is the surface area, this is the surface area, right? So if you calculate finally, so this is above the water table, and QS2 you should calculate it. So let us calculate. 13.58 multiplied by 15 plus this one 0.5 into 19.504 multiplied by 15 is 349.98. So this is 349.98 kilonewton. So therefore, you should now calculate the total axial frictional load will be QS1 plus QS2. So if you add it, you will be getting the value of QS. So QS will be therefore 349.98 plus 40.75. So this 390.73. So 390. This is the right answer. So therefore, total frictional resistance is going to be QS1 plus QS2 equal to 390.73 kilonewton. So this is the right answer that you should get it. Thank you very much. This is what I wanted to do it.